Dear students, we go to the 6th unit gravitation part 4. This is the last part of the 6th lesson. Okay, and 6.5 elementary ideas of astronomy. We go to the page 30. What is the elementary ideas of astronomy? The basic idea. Astronomy means what? You are learning about the science outside the earth. Okay, heavenly bodies. You are going to learn about the heavenly bodies. Introduction. What is astronomy? There are two more questions. It is oldest science in the history of mankind. So the science, when they started, they are thinking about the astronomy. In the olden days, astronomy was an inseparable part of physical science. It was the part of the physical science. You know what is physical science? Okay, and physics and chemistry called physical science. And it contributed a lot to the development of physics in the 16th century. In fact, Keplers laws and Newton's theory of gravitation were formulated and verified using astronomical observation. Using the observation, Kepler's law and Newton's theory was given. Verified using astronomical observation and data accumulated over the centuries by famous astronomers like Hipparchus, Aristocrates, Ptolemy, Copernicus, Tycho Brahe. So they all gave the elementary ideas. Without Tycho Brahe's astronomical observation, Kepler's law would not have emerged. So this is not one scientist have brought it. Okay, there are so many scientists. They are given the fundamental. From the fundamental, the new things were discovered. Without Kepler's law, Newton's theory of gravitation would not have been formulated. So Newton's got the idea from Kepler's, then he formulated the Newton's law of gravitation. This is all introduction, just to learn. Okay. It was mentioned in the beginning of this chapter by Ptolemy. Ptolemy geocentric model. What is geocentric model? Earth is at the center, all other planets are revolving around it. Replaced by Copernicus heliocentric model. Then it was wrong. They proved. Then the sun is at the center, all the planets are revolving around. That was given by Copernicus. It is important to analyze, explain the shortcoming of geocentric model over heliocentric system. Why? They disregard the geocentric into heliocentric. When the motion of the planets are observed in the night sky by naked eyes over a period of a few months, it can be seen that planets move eastward. Remember, when you go through the sky, and we can find out the planets move eastward, reverse their motion for a while and return to eastward modes again. Try to understand. First it appears to move eastward, then reverse. This is called retrograde motion of planets. So new concept you are learning, retrograde motion of planets. Okay, then the retrograde motion of the planet is the diagram is given. Careful observation for a period of a year clearly shows Mars initially moves eastward. Okay, and February to June, then reverse the path July, August, September. It changes direction of motion once again and continues forward motion October onwards. This is all just to learn. In olden days, astronomers recorded the retrograde motion. See how they are moving. So retrograde motion of Mars moving like this. Okay, here like this, and then visible planets and try to explain the motion. Okay, now according to Aristotle, the other planets and sun move around the earth in the circular orbit. According to Aristotle, it moves in the circular orbit. But if it was really a circular orbit, it was not known how the planet could reverse its motion for a brief interval. If it is circular motion, how it can be retrace the reverse motion. To explain the retrograde motion, Ptolemy introduced the concept of epicycle. He has introduced the new name in his geocentric model. Ptolemy, what is geocentric model? Earth is at the center, all other planets are revolving the circular orbit. So he introduced the epicycle. According to this theory, while the planet orbits the earth, it has also underwent another circular motion termed as epicycle. See the diagram, it is like this. Okay, a combination of epicycle and circular motion around the earth gave rise to retrograde motion. So combine the circular motion and epicycle. Okay, essentially Ptolemy retained the earth here, this diagram. Okay, center of epicycle, so it moves around it, then epicycle motion of planetary motion around the earth depicted with respect to months of observation. Okay, but the Ptolemy model became more and more complex as every planet was found to undergo retrograde motion. So Ptolemy says it's very difficult for every planet. Then in the 15th century, the Polish astronomer Copernicus proposed the heliocentric model. Who gave the heliocentric model? Helio means what? Sun. Okay, sun is at the center, all of the planets are revolving around. According to this model, sun is at the center of the solar system, all planets orbit at the sun. The retrograde motion of the planets with respect to earth is because of the relative motion of the planet with respect to earth. So they compare with the earth with the other planet. The retrograde motion from the heliocentric point of view is shown in the diagram. Shows that the earth moves, orbits around the sun faster than Mars. Try to understand. The speed of the earth is greater than Mars because of the relative motion between Mars and earth. Mars appears to move backward from July to October. Okay, in the same way, the retrograde motion of all other planets was explained successfully by the Copernicus model. It was because of its simplicity, the heliocentric model slowly replaced the geocentric model. This is the advantage over the geocentric model. Historically, if any natural phenomenon has one more explanation, the simplest one is usually accepted. So, always we disregard the complex one. We take only the simple one. Though this was not only the reason to disqualify the geometric model in a detailed discussion, okay, the correctness of the Copernicus model over to Ptolemy model can be found in astronomy books. Activity no need. We go to see the diagram how the planet sun, earth is moving at it. Here the change in the mass, okay, east and west, how they move. Okay, now come to very important one, 6.5 point, Keplers third law and the astronomical distance. Okay, using the third law of Keplers motion, and you can find out the astronomical distance. See the diagram, you are in the earth and you are seeing the thing horizontal and Venus is here. Okay, this is sun and Venus 46 degree and Mercury 22.5. The angle of elevation, this is called, looking upward is called elevation, looking downward is called declination. Angle of elevation for Venus and Mercury from horizon means where you are standing here in the earth. When Kepler derived his three laws, he strongly relied on Tycho Brahe's astronomical observation. All the scientists depend on the past scientists who have given that. Okay, in his third law, he formulated the relation between the distance of planet from the sun to the time period of the revolution of the planet. Very, very important. Distance from the sun to the time period. Okay, astronomers cleverly use geometry and trigonometry to calculate the distance of the planet from the sun in terms of distance between the earth and sun. To find out the earth and between the sun, okay, they use the trigonometry and the geometry. Geometry means angle. Okay, and the Venus and Mercury being inner planets with respect to earth, the maximum angular distance they can be subtended at a point on earth with respect to sun is 46 degree. Remember, 46 degree for Venus. One more question, and 22.5 degree for Mercury. Okay, when Venus is at maximum elongation, elongation means we can see the maximum part of the planet. This is called elongation. Okay, the Venus will not elongate, but we see the bigger. How you see the bigger? When it comes nearer the planet, bigger, we can see the bigger one. The planet goes away, you can see the smaller one. So elongation means the planet is not elongated. It appears. For example, you see the aeroplane. When you are aeroplane nearby, it appears to be big. When it goes at a long distance, it appears to be very small. So elongation in the sense the appearance. Okay, and the maximum elongation with respect to Earth, Venus makes 90 degree to the sun. This allows the sun to the distance between Venus and sun. The distance between the Earth and sun is taken as one astronomical unit. You have studied in 10th standard. The value. What is one astronomical unit? Is the distance between the center of the sun to the center of the earth. Okay, so the diagram is given. Now we go to this we know. Then trigonometry. What is trigonometry? Relation satisfied by the right angle triangle. You know sin theta equal to opposite side by hypotenuse. Sin theta equal to opposite side is smaller and smaller is the distance, okay, between the earth and the planet, okay, earth and the sun. Capital R is the radius of that. Okay, so here this R is one astronomical unit. Capital R is the distance between the sun and the earth. Remember, this is common for all the planet. Okay, so we want small r, so multiply capital R sin theta, R value 1 AU and sin 46. You know the one astronomical unit value and natural sin 46 and substitute we get the See the natural sine value 0.72, multiply with the astronomical unit. So all the distance given in AU, because AU is constant, we take it as a data between the earth and the sun. Okay, so Venus is 0.72 AU, Mercury is 22.5 degree, so 0.38 AU. How? Sine 22.5 is 0.38. To find the distance of exterior planets like Mars, Jupiter, slightly different method is used, because these two are given in the exterior planet. Okay, the distance of planets from the sun is given below, and this is just to understand. Okay, this is sine 30, this is sine theta, all sine theta value. Okay, comparing with 1 AU, and time period of 365.25 days, and you substitute the value. This is a cube by t square. How? 1 cube by this t square is 7.50, like that. A cube, this is A, and cube it, and the time square divide, you get this answer. It is to be noted that to verify Kepler's law, we need only high school level geometry and trigonometry, no need to go to research level. Okay, so activity, no, nothing there. Okay, we have the activity, no need. We go to the measurement of radius of the earth. How will you measure the radius of the earth? You know, radius of the earth value is 6,400 kilometer. Okay, approximately. So, how to find out? Around 225 BC, a Greek librarian, Eratosthenes, who lived at Alexandria, measured the radius of the earth. Okay, Eratosthenes, okay, and radius of the earth with a small error. What small error? Not exactly 6,380 kilometer. When compared with the results of using modern measurement. So now we have a lot of modern measurements, you can exactly find the radius. Okay, and the technique we used involves lower school geometry and brilliant insight. He observed that during the noon time of summer solstice, the sun rays are cast no shadow on the city sign, which was located 500 miles away from Alexandria. He was taken from that place. At the same day, same time, he found that Alexandria sun's rays were made 7.2 degree with the local vertical. So this theta. He realized this difference of 7.2 degree was due to the curvature of the earth. Now use the formula. Okay, the angle 7.2 degree is equivalent to how? Divided by degree into, for example, 360 degree equal to 2 pi, 180 degree equal to pi. So divided by pi, 7.2 by pi is 1.8 radian. How you got? Try to understand. You are studying in mathematics. Okay, 180 degree equal to pi radian. So 7.2 degree equal to 7.2 degree by 180 is 1.8 radian. So theta equal to 1 by 8 radian. Okay, now go to the formula, length formula. This is the length of the arc of cities and sign and Alexandria. R is the radius of the earth, cross multiply, S equal to R theta. This is the R formula you studied in 10th standard mathematics. Okay, that is equal to 500 miles. And you want R only. Okay, 500 by theta miles. But what is theta miles? 1 by 8. 1 by 8. And theta is 1 by 8 radian. So R equal to 4,000 miles. Now you convert miles into kilometer. 1 mile equal to 1.609 kilometer. Multiply, you get 6,436 kilometer. Roughly round up 6,400 kilometer. Okay, but actually it is 6,378 kilometer. Okay, the distance of the moon from earth was measured by famous Greek astronomer Hipparchus, and activity no need. We go to the next part. Interesting astronomical facts. This just to understand. So when you see the astronomical, when you read astronomical, you have a lot of things you will astonize. Okay, that is called interesting astronomical facts. First one, lunar eclipse. What is lunar eclipse? You have the moon, you have the sun, you have the earth. Okay, sun casts shadow on the moon. So lunar eclipse. Okay, and measurement of shadow of earth. So shadow of earth falls on the moon, because earth comes between the moon and the sun. Okay, they are in the same line. On January 31, 2018, there was a total lunar eclipse, fully black, fully what? Dark, the moon, full sphere appears to be dark. This is called lunar eclipse, which was observed from the various places including Tamil Nadu. It is possible to measure the radius of the shadow of the earth at the point where the moon crosses. Okay, when the moon is inside the umbra shadow. What is umbra? Very important, main shadow. Penumbra, the secondary. Primary shadow is called umbra and secondary shadow is called penumbra. You know the difference. Okay, umbra shadow, it appears red in color as soon as the moon exits. See the diagram here. See the diagram. Okay, earth, sun, here is the moon. So, earth shadow falls on. This portion is umbra and these two portion is penumbra, partial shadow, moon's orbit. You should know to draw the diagram. Total lunar eclipse. And it appears in crescent shape. Crescent shape, this is called crescent shape, where partly you get the light. A digital camera during next exit from the umbra shadow. Finding the apparent radii of the Earth's umbra shadow and the moon, the ratio of the radii can be calculated. That is here. Okay, schematic diagram of umbra, disk radius. This is called disk radius. Okay, so that's how much? 13.2 centimeter, and you have to multiply the apparent radius RM equal to 5.15. Those two divide, you get 2.56, and multiply by RS equal to 2.56 to RM equal to the radius of the moon is 1737 kilometer. Remember, earth radius is 6,400 approximately. This is nearly 1,700 kilometer. Okay, the radius of the earth umbra and multiply, you get 4,446 kilometer. Correct radius is 4,610 kilometer. But percentage of error you have to calculate. You have to original minus the calculated and divide by original into 100 equal to 3.5%. The error will reduce the picture if taken using high quality telescope. So, if the telescope is high quality, we can make it. It is to be noted that this calculation is done using very simple mathematics. Okay, early astronomers proved that Earth is spherical in shape. Okay, and by looking at the shape of the shadow cast by Earth on the moon during the lunar eclipse, from that only Earth they thought is a spherical shape. Okay, using the lunar eclipse. Second one, why there are no lunar eclipse and solar eclipse every month? Why can't you get every day, every time? Okay, lunar eclipse and solar eclipse. Okay, if the orbits of the moon and earth lie on the same plane during the full moon of every month, we can observe lunar eclipse. If this is so during new moon, we observe solar eclipse. New moon means what? Paurnami. Okay, full moon day. But moon's orbit is tilted 5% respect to Earth's orbit. Due to this 5% tilted only during certain periods of the year, the sun, earth and moon align in straight line. Try to understand? See, because of the tilt. Okay, turning to 5 degree and earth and moon, and we have to either lunar eclipse or solar eclipse depending on the alignment. What is alignment? And sun, earth, moon on the same line. This is called alignment. Okay, why do we have seasons on earth? Okay, you studied in geography. Now in physics, how you get the seasons? The common misconception is that earth revolves around the sun. So when the earth is very far away, it is winter. We thought that earth is away from the sun because the sun will be at the two foci of the ellipse. Okay, when it is nearer, it is summer. When it is further, it is winter. Actually, the season the earth arises due to the rotation of the earth around the sun with the 23.5 degree tilt. This is shown in the figure. Due to this 23.5 tilt, when the northern part of the earth is farther and to the sun, the southern part is nearer the sun. So, when it is summer in the northern hemisphere, southern experience the winter. Remember, one side is day, other side is night, like that, upper surface and lower surface. Okay, upper surface is northern hemisphere and lower surface is southern hemisphere. Okay, see the diagram, sun, new moon, no eclipse, new moon, solar eclipse. Okay, try to understand. You should know to draw the diagram, spring, atom and that and all they are given. Now we go to the stars apparent motion and spinning of the earth. What is stars apparent motion? Sun is a star. Like this, there are numerous stars around the sky. Okay, in the universe. How they are moved? Okay, when they are moving away, recede. Okay, when they are coming towards, we are going to use shift. Okay, violet shift and red shift from the VIBGR. Okay, So, the Earth's spinning motion can be proved by observing star position over a night. Due to Earth's spinning motion, the star appears to move in circular motion about the pole star as shown in the diagram. Okay, what is a pole star? It's a star located exactly above the Earth axis rotation, hence it appears to be stationary. Where? North pole or south pole. The star Polaris is our pole star. What is the name of the pole star? Star Polaris. Point to ponder. You got to remember. Use a sunrise and sunset. How will you prove that Earth tilted 23.5 degree? Then we have to do it as a homework. Okay, pole star here. Okay, it appears to be star apparent circular motion due to Earth motion. Here is a pole star. Okay, now recent developments and of astronomy and gravitation. Now, latest. Even if you finish BSc Physics and MSc Physics and MPhil Physics and PhD Physics, you can do the research. So, there are recent developments, okay, and gravitation till the 19th century. What is 19th century? From 1800 to 1900. Remember carefully. Astronomy mainly depend upon either observation with the naked eye or telescope. When naked eye means you just go up to the house or a very big building, you observe the sky. This is called naked eye. You are using your own eye. Another one, telescopic, using the telescopic observation. High resolving power telescope is there. Okay, and after the discovery of the electromagnetic spectrum at the end of the 19th century, our understanding of the universe increased enormously. Okay, only this 20th century. What is 20th century? From 1900 to 2000. Okay, because of this development of late 19th century, it was found that Newton's law of gravitation could not explain certain phenomena and source of discrepancies. So, it is Newton's law of gravitation, only the attraction only showed. What about other things? So, they want to do the next one. Albert Einstein proposed general theory of relativity. He started with the relativity. What is relativity? Imagine you are walking, but when you see from the train or bus, what you can say, tree or building will move in the opposite direction. So, when even the permanent which is not moving, okay, which is at rest also appears to move. That is called relativity theory. For relativity, we need the two things. One is rest, another is moving. Rest and motion, comparing with two frames, rest frame and moving frame. So, that you are going to study in Newton's law of theory of relativity. Okay, so general theory of relativity, which was one of the most successful theory in the 20th century in the field of gravitation. In the 20th century, both astronomy and gravitation merged together and have grown in manifold. They combine together the birth and death of stars. The stars, how they are born, how they die. Die means what? You cannot see. It appears to go to the long distance. Okay, many Indian physicists were very important contribution to the field of astrophysics and gravitation. Example, Ramaniyam Sankara formulated, he is an Indian, formulated theory of black holes. What is black holes? When there is no emission of light rays, it appears to black. Okay, and explain the life of stars, how the star birth emerges and again dies. Till that, okay, that is called life of stars. These studies brought him the Nobel Prize in the year 1980. Who got? Our Indian scientist Ramaniyam Sankara. Another very notable Indian astrophysicist, Magnat Saga, discovered the ionization formula which was useful in classifying the stars. How double stars, multiple stars, classifying. Okay, single stars. Our sun is a single star. Okay, the Saga ionization formula in the field of gravitation, Amal Kumar Rai Chaudhary solved an equation known as Rao-Chaudhary equation, which was very important contribution. Another notable Indian astrophysicist, Jayant V. Narlikar, made pioneering contribution in the field of astrophysics and has written interesting books on astronomy and astrophysics. Okay, IUCAA, Inter-University Center for Astronomy and Astrophysics, one of the important Indian research institute where active research in astrophysics and gravitation are also conducted. You can also, after finishing MSc Physics, you can join the research and you can also find new things in the astronomy. Okay, the institute was founded by Professor J.V. Narlikar. Students are encouraged to read more about the recent developments in these fields. Okay, the lesson is getting over. Okay, and this lesson over. Try to send the assignment as usual. Okay, we continue the next lesson in the next part. Thank you.